In this lecture, we're going to be discussing multiplication, permutations, and combination probability formulas. By the conclusion of this lesson, what you're going to be able to do is determine the number of possible outcomes by using multiplication, permutation, and the combination formulas. First of all, multiplication formulas essentially states that there are n number of ways to do one thing and m number of ways to do another thing. And then there are m times n ways of doing both things. For instance, with the multiplication formula, with cars, an automobile dealership dealer wants to advertise that for $22,999, a two-door or four-door model with your choice of gray, blue, green, or orange can be yours. How many different vehicles can that dealer offer? And that would be there's four colors. There's two body styles, so therefore there's a total of 4 times 2, which would be 8. Another example is rock, paper, scissors. There would be 3 possible choices for the first person, 3 possible choices for the second person. So there is a total of 3 times 3, which would be 9 possible choices for both, both the first and the second person, combined if you look in that order. And there's a lot of applications for this. So just be aware of the multiplication formula. You will be using this one a lot. Next, the permutation formula. This one, when you see permutation formula, when you see a P, it order matters, okay? It's a counting formula to determine a total number of outcomes. It's any arrangement of R objects selected from a single group of n possible objects. Okay, so there is a total of n possible objects. Once again, I'm dealing with color in this example. N is the total number of objects. R is the number of objects selected. Okay. The football team is deciding on a new helmet. They have 4 colors to choose from: black, gold, white, and green. Technically, there's 5 that you could choose from, but I don't know if you want to put brown on a helmet, so we're just going to stick with those 4: black, gold, white, and green. And no color will be repeated on the face mask, letters, or helmet color. How many different options can they have? There are a total of 4 colors to choose from to design the helmet, so n equals 4, and because only 3 colors are chosen, r equals 3. If you want to pause this and work that out before we move on to the next screen, I'd suggest you do that. And I'm going to move on to the next screen now. Okay, so 4 factorial over 4 minus 3 factorial. So 4 factorial is 4 times 3 times 2 times 1 equals 24. And just a reminder, 1 factorial or 0 factorial equals 1. So if there were 4 possible color choices, if we could give the chin strap a color choice, it wouldn't change the number of options. Okay, so for the helmet, if you were to have a gold helmet, there are 6 different options with a gold helmet, 6 different options with a green helmet, 6 different options with a white helmet, 6 different options with a black helmet. For a total number of 24. Notice here when we're talking about permutations, the order matters. Okay, let me say that again. Permutation, the order matters. Okay, combination formula. Order does not matter with a combination formula. Okay, order does not matter. This is another counting formula in determining the total number of outcomes. A combination is an arrangement where the order of the objects selected is not important. Okay, n. Okay, so n is the total number of objects. R is the number of objects selected. So it's n factorial over r factorial multiplied by n minus r, and then you take the factorial of the of the n minus r. Well, you multiply r factorial minus the n minus r factorial. Okay, so the candy store uses teams of 3 employees to work each evening. There are 7 employees available to work. How many different teams can be scheduled? Okay, so if you want to work this out, it would be 7. Okay, because there's 7 employees, so that's the total number of objects or people. 7 factorial over 3 factorial multiplied by 7 minus 3 factorial. Okay, so you take 7 factorial, um, and then you multiply 3 factorial by 4 factorial, and then you take 7 over 3, or, I'm not, if you wanted to, you could take 7 minus 7 factorial. Yeah, just do it like that. You can look up how to divide and multiply factorials a little bit easier, but I'm not going to do that in this lecture. So that is the conclusion of the combination formula, the permutation formula, and the multiplication formula. You're going to utilize these quite a bit, so make sure you understand how each one of these works. Once again, combination order does not matter. Permutation order does matter, and multiplication, you're talking about two separate ways of doing things within the same event. So order does also matter there. If you have any questions about this, feel free to post it to the discussion board, and